My name is Wakisa Kana. I'm from Ethiopia and currently I'm a student of BIT University and BTech, and my department is Electronics and Communication Engineering with a specialization of Biomedical Engineering. And now I'm going to give you some pointers on the advanced data structure, specifically under the topic of tree. Advanced data structure. There are so many advanced data structure. Among this, I'm going to focus on the tree. I want to give you some points about tree. Tree data structure. A tree is an advanced data structure that is sometimes also known as prefix tree or detail tree. It is a tree that stores the data in an ordered and efficient way. We are using this tree for storing data. Generally, this tree used to store strings. Each node of a tree can have as much as 26 references or pointers. Each node of a tree consists of two things. We will see two things. These are a character and a Boolean value. This Boolean value is used to implement whether the character represents the end of the word. And also, when I'm going to the next slide, when I'm going to this tree comes from retrieval. This term was coined by Edward Franklin, who pronounced this tree as the word of retrieval. A data structure for representing a collection of strings is this tree data structure. In a computer science, a tree, also called digital tree, and sometimes radix tree or a prefix tree. We can say a prefix tree or radix tree, or sometimes we can call it as a, a radix tree. And also, this tree supports fast pattern matching. Let us see some properties of a tree. There are so many properties of a tree, but I put these four main properties of a tree. A tree is a multi-way tree, and also each node has from 1 to n children. Each edge of the tree is labeled with a character. Each leaf node corresponds to the stored strings, which is a concentration of characters on a path from the root to this node. So we can categorize this tree into three different parts. These are, the first one is standard tree. The standard tree for a set of strings S is an ordered tree such that we can say that each node but root is labeled with a character, and also the children of a node are alphabetically ordered. It's supposed to be as alphabetical. The path from the external nodes to the roots yields the strings of S. Also, let us see the operation of insertion in standard trees. The operation. I'm taking the example of this one, the set of strings which are specifically an, and, any, and at. I have I took these roots, and these are branches. These are branches. A and firstly I have to write this end. First I have to write this end, and I have to write like this: A, N, and D. This T and the Y is as a branch, because to make at and to make N. And This an is this one. To make an we can get from here. From here we can get, but add and any to get add and any we have to see from this and also this one. Why? Any we can get that. So you can see from this slide I'm showing you, and also another example of standard tree is example of another example. This is I took a set of beer, bell, bid, bull, buy, sell, and stop, and also stop. I took this 1, 2, 3, 4, 5, 6, 7, and 8. 8 elements I have taken, and also I put structurally as such way. You can see from this. You can see from this. First of all, I took this this beer. I took this beer. You can see from this here B is here, and also is here, A and R. You can see from this beer. When we read this one, it becomes beer. Structurally, we are I have put this one like this, and also you can understand another things like I have encircled the word I have used here, beer. I have encircled it like that. You will get all these elements from this structure. So standard tree structure used to push some sets to in structural form. This is another advantage of standard tree. So when we come to this handling keys, these or strings, when a key or string is a prefix of another key, we use this one when a key or string is a prefix of another key, and also this is how can we know that an the an is a word, is it a word or not? How can we know? We have to draw the structure, and we can get the an is we can verify it as an is a word. You can see from this slide. You can see from this slide this an. I think you understand it. And also we add a special termination symbol, which is the dollar symbol at the end of each children or each branch. At the end, we can add. This is used as a what? As a termination symbol. We append this termination symbol to each keyword of the strings. Also standard trees, when we now I'm going to do the operation of searching on standard trees. I want to search this c word in this structure. Where is c? I have to search this one. For example, you will find c here. You will find it here. This is how to search the C from the given structure of the trees. Now the operation of deletion in a tree. The operation of deletion in a standard trees. On this deletion operation of deletion, we will see three main idea. Those are there's three main idea. Number one, this one, word not found. The second, word exists as standalone word. The third one and the last one, word exists as prefix of another word. These three main cases are included under deletion, and also we will get here. Delete C. On the first slide, we were seeing I have mentioned searching the C, now deleting the C from this structure. Deleting the C from this structure. You can see from this it is deleted. Also, word exists as a prefix of any other word. Delete an. An is exists as a prefix. You can see from this. You can see from this. You can see from this. This one is a operation of deletion. And also compressed. Compressed is this. Compressed means reducing the size. Also sometimes reducing the quality also reduced when you compress something. The quality also reduced, size also reduced. There is a video reduction, audio reduction, PDF reduction, text reduction. Everything is there. Reduction or compression. I mean compression, video compression, audio compression. There is a compression for everything. So now compression trees. In this case, we use the compression in a trees. Trees with notice of a degree at least how much? 2, obtained by standard trees by compressing chains of redundant nodes. By compressing redundant, which is repeated in a trees, we have to compress that one. Compress the example. When we take example, the standard tree given first. This we have. I have mentioned this one before. So this one is given. We have to compress this one to another tree. The compressed form of this structure is here. You can get from this compressed form of this one. Let's come to suffix trees. Suffix trees. A suffix tree is a compressed tree for all the suffixes of a text. This is a compressed tree for all the text. Suffix tree are a space or efficient data structure to store what? A string that allows many kinds of queries to be what? To be answered quickly. Suffix tree are what? This is the main advantage of tree. Suffix tree are what? Space efficient data structure to store what? A string that allows what? Many kinds of queries to do answered quickly. We have to understand some point from here. This is the main advantage of trees. Example of suffix trees, I have mentioned it. This is the example of suffix trees. By considering this one, the example of what? Example of suffix trees. And also example of suffix tree. A second example, I took this one. It should be written alphabetically or orderly. After we have alphabetically ordered that one, we can structure it as such way, and also we have to put the termination. These are termination symbol. Termination symbol. I have mentioned this one. I have presented this one on the first slide. This is what? This is termination. Termination. This is all termination, which is what? Which is put at the end of each node, at the end of each what? Each children. Understanding what we understand from what we have seen till now, understanding requirements. This one is we have to understand these 3 points. From we have seen searching, insertion, deletion, operation. We have seen this all things. From this, what we understand means insertion is what? It is a fast as compared to the hash table. We have been understand this one, and also lookup is much more faster than what? Hash table implementations. And also there are no collection of different keys in a tree. There will be not happened in a trees the collection. This is by the way, we will see this one in the advantages of trees. This is the main advantage of trees. We will see it in the next slide. We will see this one is advantage of trees. Find collection of different keys. Tree application. The most common use of trees in real world is the autocomplete feature that we get in search engine. Now everywhere it is there. Everywhere it is there. After we type something in the search bar, the tree of the potential words that we might enter is greatly reduced, which in turn allows the program to what? Enumerate what kinds of strings are possible for the words we have typed in. What we have typed in the search bar, we will get in the what in the strings we will get it. So to show, for example, we will type something before. When we when we type it again, we will get that one. This is the advantage, the application of what trees, and also tree also helps in the what in the case where we want to store additional information of a word. Say, let's say the popularity of the word, which makes it so powerful. We might have seen that when we type food on the search bar, we will get football because this football is well known word, very known word. That's why we get football before anything. For example, we want to search food patch, food something, but we will get immediately football because this football is what it is much popular than the word that we are finding. Also, three also helping in checking the correct spellings of a word. Yeah, this is the application we are look at in we are studying now. The application we are using in our daily life, as the past is similar for a slightly miss. And also string matching is another case where trees to exist. The advantages of trees. I don't want to take a time to explain this. You can read from this one, advantages of trees relative to binary search tree, and also advantages of trees related to hash table. There are so many advantages of trees. I have I told you before in a series of slides. I was appointing at advantages. Is that one only I summarized and put here. Yeah, I summarized the advantages, what we have seen in entire slides, and there is no collision. There is enough space to reduce the space. These all things are advantages of trees, and also later some disadvantages of the drawbacks of trees. Trees can be slower in some cases than hash tables. It is slower, it has no speeds for looking up data, especially if data is directly accessed on a hard disk drive or some other secondary storage device where the random access time is high compared to what main memory. It is not easy to represent all keys as string, such as floating point numbers, which can have multiple string representation for the same floating point number. For example, if we take 1, 1.0, 1.00 plus 1.0 extra, we cannot represent this one in a tree. This is the main drawbacks or disadvantage of this. These all are what? These all are the main drawbacks or what? Disadvantage. Disadvantage. This is the disadvantage. The disadvantage of, and also it is not easy to represent it. This one I told you. The trees are frequently less specific than hash tables. In this also, unlike hash tables, trees are generally not already available in programming language. We cannot access in a programming language. This is the main drawback of what trees. Thanks for watching this one. Thanks so much. Also, I would like to thank my professor, Jasmine. I would like to thank you so much to giving this chance to present my assignment. Thank you so much.